Newton's first law of motion states as follows. An object moves at a constant velocity unless an unbalanced force acts upon it. This basically means that when you kick a soccer ball that is at rest, it will move. Duh. Here's an example in depth. If you take a cup of water and put it down on a table, it will stay there because no forces are acting on it. But what happens if you unfortunately bump your elbow on it by accident? Oh, why did I make these examples? The elbow hitting the cup creates an unbalanced force that makes the cup tip backwards, spilling all the water from the cup onto the carpet.
Ah, no, the carpet!
Here's another example. If you ever heard the first law being called the law of inertia, here's why. When you have this Lego car having a constant velocity with a camera screw on top of it, the camera screw will continue to move without the car. This is because of inertia, or an object to resist any change of motion. The car has stopped, but the screw keeps moving forward because it didn't encounter any unbalanced forces stopping it. Now, let's check in with Splat Apple, who is currently writing the script. It is currently 11:21 p.m. How are your thoughts? Great, but can't you go any faster? I feel like I would have finished writing this simple script ages ago. Wait, why are you looking at me like that? No. Stop. No, stop somebody up! Up next, the second law. Newton's second law of motion describes that the forces exerted on an object, its mass, and its acceleration are related. This one is a little bit complicated, so much that it took me 5 hours to complete this part of the script. This equation, net force equals mass times acceleration, is basically the definition of Newton's second law. A total force or net force can be figured out by multiplying mass and acceleration can be figured out by dividing the net force by the mass. When the mass is bigger, it takes more force to move that object. This law only applies to objects with unbalanced forces. Suppose Billy was pushing a cart that weighed 15 kilograms. If it was accelerating at 2 meters per second, that means Billy would have to push 30 newtons worth of power to make the situation valid. Lastly, Newton's third law of motion states that when one object exerts a force on a second object, the second object exerts a force on the first object that is equal in strength and opposite in direction. When you apply a force on something, that something will bring the opposite force right back at you. So picture this. Imagine you are having a really heated argument with a wall about that time when it stubbed your pinky toe. Oh my god! You try to push the wall, but it seems like it doesn't move. That was Newton's third law in action. When you apply force to the wall or push it, it creates the same force back to your hands. Returning to the example I used in the first law of motion, the third law of motion defines why the cup is stationary. The force on the table from the cup results in the table exerting an equal but opposite force, which is why the cup doesn't move. That was a long script to read. Now let's check in with Splat Apple, who is currently editing this video. Okay. He's gone. Yeah, he's gone for sure.